You see them everywhere on posters, your takeout container, a bus stop ad, maybe even on the back of a ketchup bottle. These little black and white squares, these pixelated messes, have become a silent part of our daily lives. You point your phone at them, and like magic, a menu pops up, a website loads, or you're suddenly on the Wi Fi. But have you ever stopped to wonder what this secret language is actually saying? Because it's not random, not a single dot. Every single square in that grid has a hidden purpose, a specific job that makes the whole thing tick. From the big blocks that help your phone find the code in the first place, to the tiny dots that allow it to be scanned even when it's torn or smudged. This isn't just a picture, it's a masterpiece of data design. So in this video, we're going to decode the secret structure of QR codes. Let's begin by explaining what QR codes are and how they actually work. To answer that, it helps to go back for a second to the barcode. For a long time, barcodes were the standard way to label and track products. You've seen them a million times at the grocery store or on a delivery box. Barcodes are just a row of black vertical lines scanned at checkout, and they work well, but they have limits. A regular barcode can only hold a small amount of information, usually just a product number. And it has to be scanned in one direction, which makes it useful but not very flexible. As technology moved forward, companies needed something better. They needed a code that could store more information and be scanned faster and more easily. That is where the QR code came in. QR stands for Quick Response. It was invented in 1994 by Denso Wave, a company connected to Toyota. The goal was to create a code that could hold much more data than a barcode and still be read quickly from different angles. And that is exactly what made it so powerful. Unlike a barcode, which is one-dimensional, a QR code is two-dimensional. Instead of storing information in just one direction, it stores it across both the width and the height of the square. That one change made a huge difference. Suddenly, a small code could hold much more information. Not just numbers, but letters, website links, and other types of data too. And that is why QR codes became so useful. But here's where it gets really interesting. A QR code is not just a block of data, it is actually built in layers with different parts doing different jobs. At the most basic level, it is made of tiny squares arranged in a grid. Those squares are called modules. Some are black, some are white, and together they create the pattern your phone reads. But not all of those squares are the message itself. Some of them are there to help your phone understand what it is looking at. For example, the white border around the outside is called the quiet zone. That empty space helps your phone separate the QR code from everything around it. Without that border, the scanner might struggle to tell where the code begins and ends. Then there are the three large squares in the corners. Those are called finder patterns. They help your phone instantly recognize that the image in front of it is a QR code. They also help it figure out the code's orientation, so whether the code is straight, tilted, or sideways, your phone can still make sense of it. And on some QR codes, especially larger ones, you will also see smaller square patterns inside the code. These help with alignment. So if the code is printed on something curved, like a paper cup or a crinkled package, your phone can still adjust and read it correctly. There are also timing patterns which help the scanner understand the spacing of the grid itself. In other words, before your phone even reads the message, it first has to understand the structure. And once it does, it can finally get to the actual data. That data is stored in binary, using the pattern of black and white squares. Your phone scans that pattern and translates it into something useful, like a web address, a message, or a password. But one of the smartest things about QR codes is this: they can still work even when they are damaged. That is one of the reasons they became so successful. A QR code can be scratched, smudged, dirty, or partly covered up, and there is still a good chance your phone can read it. That is because of something called error correction. When a QR code is created, it does not just store the main message. It also stores backup information. That way, if part of the code is missing or unreadable, the scanner can rebuild the missing pieces. That is why some QR codes still work even when they look damaged. It is also why companies can sometimes place a small logo in the middle and still have the code scan normally. And there is one more clever detail hidden inside the design, something called a data mask. A data mask does not hide the information. It simply changes certain black and white squares so the overall pattern is easier for scanners to read. Without that step, the code might accidentally form shapes or patterns that confuse the camera. So the mask helps make the code cleaner and more reliable, which means even the visual layout is carefully controlled. And that is what makes QR codes so impressive. They may look like random little boxes, but they are actually a well organized system built for speed, accuracy, and durability. They help your phone find the code, understand its shape, read the message, and even recover information if part of it is damaged. That is a lot happening inside one small square. So the next time you scan a QR code, it might look a little different. Not just like a shortcut, not just like a bunch of black and white pixels, but a smart piece of design that quietly connects the physical world to the digital world in a single scan. Thanks for watching, and I'll see you in the next video.